When we look up at the night sky, we're peering into an ocean of time and space, searching for an edge that doesn't exist. The universe isn't expanding into anything. Space itself is stretching, with every point moving away from every other. Picture a raisin loaf rising in the oven. Every raisin moves away from the others, but there's no center or edge. This is our cosmos, a dynamic, growing entity that defies our intuition about boundaries. The light from the farthest objects has traveled billions of years, but those objects have moved even farther away in that time. So, the universe is much larger than the distance light has traveled since the Big Bang. We're always chasing a receding horizon, the edge of what we can see, not the edge of what is. Edwin Hubble's discovery that distant galaxies are moving away from us revealed the universe's expansion, a revolution in our understanding. The Hubble constant measures this expansion, helping us estimate the universe's age and size. The observable universe is a sphere centered on us, limited by how far light has traveled in 13.8 billion years. What lies beyond? We don't know. Perhaps more of the same, or maybe infinity. The universe we see is vast, but it may be only a tiny fraction of the whole. We are explorers on a small island in a cosmic ocean, just beginning to map our shoreline. To explore the cosmic abyss, we need powerful eyes, like the James Webb Space Telescope, or JWST. Launched in 2021, JWST sees the universe in infrared, capturing ancient light stretched by cosmic expansion. It's a time machine, revealing the first stars and galaxies, and challenging our theories about how quickly the early universe evolved. JWST isn't just confirming what we thought, it's rewriting the universe's origin story. By studying exoplanet atmospheres, it searches for signs of life, bringing us closer to answering, are we alone? In a single deep field image, JWST reveals thousands of galaxies in a patch of sky the size of a grain of sand. Hubble estimated 2 trillion galaxies. JWST suggests there may be even more. What we see is just a sliver of reality. The universe is not just bigger than we imagine, it's bigger than we can imagine. To grasp cosmic distances, let's start with our solar system. Driving to the moon at 100 kilometers per h would take 160 days, to Mars over 60 years, to Neptune more than 5,000 years. Even light, the universe's speed limit, takes 8 minutes to reach Earth from the Sun, and over 4 hours to reach Neptune. We always see the solar system as it was in the past, a mosaic of different moments. Voyager 1, launched in 1977, is now in interstellar space, over 22 light-hours away. After decades, it's barely left our cosmic front porch. To reach the next star, Alpha Centauri, would take Voyager 1 about 75,000 years. The space between stars is almost unimaginably empty and vast. Our solar system is a tiny oasis in a desert of near-perfect vacuum. These numbers become abstract, but they highlight just how isolated we are. Even our fastest probes are crawling across the cosmic landscape. The distances between stars dwarf anything in our solar system. We are truly alone in our little corner of space. Zooming out, our sun is just one of 100 to 400 billion stars in the Milky Way. Counting one star per second would take over 3,000 years to reach a billion. Multiply that by 100 for our galaxy's population. The Milky Way is a spinning disk about 100,000 light-years across. Light from the far side takes 100,000 years to reach us. We see ancient history in every direction. We're about 27,000 light-years from the galactic center, home to a supermassive black hole, Sagittarius A*. Our solar system orbits the galaxy at 828,000 kilometers per h, taking 230 million years for one revolution, a cosmic year. The last time we were here, dinosaurs were just appearing. The faint band of the Milky Way in the night sky is the combined light of billions of distant stars. All the stars we see with the naked eye are our immediate neighbors. We are embedded within a vast, swirling city of stars. Our perspective is from inside, looking out. We are a single grain of sand on a galactic beach. The Milky Way is part of the Local Group, a family of over 50 galaxies bound by gravity. The Local Group spans about 10 million light-years, mostly dwarf galaxies orbiting the giants, the Milky Way and Andromeda. Andromeda, our nearest major neighbor, is 2.5 million light-years away. Its light left when early hominids walked Earth. It's the most distant object visible to the naked eye, a ghost from the deep past. Andromeda isn't moving away. It's heading toward us at 400,000 kilometers per h. In about 4.5 billion years, the Milky Way and Andromeda will merge. This won't be a violent crash. Stars are so far apart that direct collisions are rare. The galaxies will blend into a new, larger elliptical galaxy. Our sun will likely be thrown into a new orbit, and the night sky will be transformed. Galactic mergers are a fundamental process in cosmic evolution. Galaxies grow and change by consuming one another. The universe is shaped by these grand, slow-motion collisions. Beyond the local group lies the Virgo cluster, a bustling metropolis of over 1,300 galaxies, 54 million light-years away. Its gravity is so immense it affects the motion of our local group, pulling us toward it. The cluster's core is dominated by giant elliptical galaxies like Messier 87, home to a supermassive black hole 6.5 billion times the Sun's mass. The Virgo cluster is a dynamic, violent place where galaxies interact and evolve. We're on its outskirts, far enough to avoid the chaos, close enough to feel its pull. Our cosmic address grows more complex. Earth, solar system, Milky Way, local group, Virgo cluster. Each step outward reveals a new layer of structure. The universe is anything but random. In 2014, astronomers discovered that the Virgo cluster is just one part of a much larger structure, the Laniakea supercluster. Laniakea, meaning immeasurable heaven, is a continent of galaxies, over 100,000 in all, spanning 520 million light-years. All these galaxies, including ours, are moving toward a mysterious region called the Great Attractor. The Great Attractor's true nature is hidden behind the Milky Way, but its gravity draws our entire supercluster at 2.2 million kilometers per age. Laniakea redefined our cosmic address. We are part of a supercluster, not just a cluster. Supercluster boundaries are defined by gravity and motion, not clear lines. Step outside Laniakea, and you enter another supercluster's domain. The universe is a tapestry of these immense interconnected structures. Our place in the cosmos keeps expanding. Zooming out further, the universe reveals its grandest structure, the cosmic web. Galaxies are arranged in vast filaments and clusters, forming a three-dimensional web across hundreds of millions of light-years. Where filaments intersect, superclusters like Laniakea form. Between them lie immense empty voids. In a void, the night sky would be almost completely dark. This web is a fossil record of the universe's earliest moments, shaped by gravity and dark matter. The cosmic web is dynamic. Galaxies collide, black holes feed, and stars explode in supernovae. Matter and energy are recycled on the grandest scales. The universe is not static but an evolving ecosystem. We are part of this cosmic web, connected to everything by gravity and history. The grand design is written across the heavens. To understand the universe's origin, we look to the cosmic microwave background, the faint afterglow of the Big Bang. This ancient light was released when the universe became transparent, 380,000 years after the Big Bang. As the universe expanded, this light stretched into microwaves, filling the sky as a uniform glow. Tiny temperature fluctuations in the CMB are the seeds of all cosmic structure, galaxies, clusters, and voids. By studying these patterns, cosmologists determine the universe's age, composition, and shape. The data suggests the universe is flat and possibly infinite. The observable universe, a sphere 46.5 billion light-years in radius, may be just a tiny patch of a much larger reality. The CMB is our baby picture of the cosmos. It connects us directly to the moment of creation. The universe's story is written in this ancient light. We are reading the opening chapter. We've reached the edge of what we can see. The observable universe, 93 billion light-years across. But there's no reason to think the universe ends there. Most cosmologists believe the universe beyond our horizon looks much the same as within. Some theories suggest the universe is trillions of times larger than what we observe, perhaps even infinite. In such a vast cosmos, every possible configuration of matter could exist somewhere. This leads to the idea of parallel universes, regions so distant they're forever out of reach. If the universe is infinite, there could be infinite versions of you, living every possible life. Our existence is precious but not unique in the grand scheme. We are one story among countless others, scattered across an immeasurable heaven. To study the universe is to study ourselves. Our journey inspires us to keep looking up, to keep asking questions, and to marvel at the cosmos we call home.